Hi, everyone. Welcome to another K6 office hours. We were gone last week, but we are back this week, this time joined by Sid Palas. Oh, by the way, I'm Nicole van der Hoeven.
And I'm Simme.
And this is Sid Palas. Sid, do you want to talk about who you are, what you're doing here? What do you do?
I'd be happy to. Yeah, thank you for having me. My name is Sid, as Nicole said, and I am a software engineer mostly focused on DevOps and cloud infrastructure topics. And I split time between technical consulting, usually for Series A and seed stage startups, sort of helping them build out and improve on their infrastructure and DevOps practices. And then the other part of my time, I'm building out content for YouTube and my blog at devopsdirective.com.
I really love your YouTube channel, by the way. It has a lot of
Thank you.
beginner-friendly stuff about Docker. I watched a few of them.
Cool. Yeah, it's been a fun journey. I started it just over a year ago. And yeah, it covers a lot of Docker. I'm getting some Terraform content going. I've touched on Kubernetes just a little bit. But yeah, YouTube's an interesting platform where it starts slow, but then it starts to grow.
Yeah, and that's
Yeah.
actually DevOps Directive is actually why you're on as well, because I think it was about a year ago, maybe, or a year and a half that we
Yep.
first got into touch when you did a cool article about running K6 against caddy servers on GCP, if I remember correctly.
Exactly. Yeah. So my initial setup for the DevOps Directive website was with a caddy server running on an F1 micro, so the smallest instance that Google has. Doesn't even have one full vCPU. But for serving a static website, that's perfectly fine. And I was able to use K6 to do a load test and sort of confirm my suspicion that it would be perfectly fine. And then a couple of times I've had articles make it to the front page of Hacker News, which brings a lot of traffic, and it had no issues at all. So it was cool to sort of see the testing up front and then proven out with a real load with no issues.
So what drew you to K6 to begin with?
Yeah, I wanted to. I just kind of searched for which options there were in the load testing space, and it had a really nice JavaScript interface that seemed simple to use, and so I got spun up, and within 20 minutes I had a test ready to go, and so yeah, it was just the simplicity and the accessibility of the tool.
I know you're doing a lot of SRE work now or DevOps work, but do you have a developer background, or how did you get into to that whole business?
Sure, yeah. So all of my academic degrees are actually in mechanical engineering. I studied
Nice.
mechanical engineering undergrad. I did a master's in mechanical engineering. My first few jobs were kind of I was in the aerospace industry as a research scientist type role. So it was kind of a mixture of mechanical plus software. And so at that time, I was still a mechanical engineer who could code, but I wasn't really a software engineer, I would say. I was getting better and better, but I didn't have sort of the experience to work within a large code base on a large team effectively. And so those were skills that I sort of picked up along the way. And I found that the portions of my job where I was writing code and working on the software were the most exciting to me. And so I slowly volunteered for more and more of those types of tasks until I had transitioned from 100% mechanical to maybe 60 or 70% software. And at that point, I decided to go all in on software. This was, I guess, in 2017, 2018. And so I applied to a bunch of jobs here in San Francisco. And the clearest path to move into software, at least here in Silicon Valley, is within web. And so I joined a health tech startup that was building a platform for helping to bring together patient medical records from all the different siloed EMRs where they exist and sort of bring them into a single platform and add a layer of intelligence on top of them. And so that was my first full software engineering role in a web application company. And so there, I was doing full stack things, and I was best at and found the most exciting, all the infrastructure pieces. And so building out our infrastructure as code configuration, working on our Helm charts for how we're deploying these applications into Kubernetes. And I think that sort of the system level thinking that DevOps and SRE and cloud infrastructure work requires really came naturally to me and was a great fit for how I like to approach these engineering problems.
That's really good, and I love that you came to tech from a non-traditional background. I came from an economics background, actually, so I don't know what I'm doing in tech, but I love it.
Awesome.
Yeah,
Yeah,
and
I
same
think
here. I studied pedagogics and then some informatics after that, but no formal degree in anything related to what I'm doing. So it's cool to see others who are taking the same path.
yeah, I do draw upon sort of the same engineering mindset and skill set, even if it's not directly designing or building mechanical systems anymore. Now it's software systems, but I think there was a lot that I gained from that engineering degree, just in terms of how I approach problems and breaking things down into their constituent parts. But yeah, it's been an interesting transition, and definitely those first few years working in software was drinking from a fire hose. There's just so many pieces that go into building an application and deploying it into the cloud that it can be an overwhelming experience to try to ramp up on quickly, for sure.
So I think that a lot of it has to do with the attitude, because IT is a multidisciplinary discipline. It's not like you have to be just good at one thing. I think what's more important is the attitude of always looking to the next thing and wanting to learn and trying out things, because there's some technologies that are so new that we're all beginners to it.
Yeah.
Definitely. I think holding on to that beginner mindset and being willing to admit when you don't know something and seek out assistance from someone who either knows more about that topic or maybe just has more context about the problem that you're facing. That could be context within the business. That could be context within the industry that you're focused in, and being willing to raise your hand and say, "Hey, I'm stuck. I don't know exactly where to go. How do I get unstuck?" And
I've
balancing.
actually done, sorry.
No, I was just going to say balancing sort of the willingness to ask for help with the need to really dig in, at least at first, and try it yourself personally, so that you do sort of have the scaffolding to slot in that knowledge. And so I think figuring out that right sweet spot is a really important thing for anyone in their software engineering journey.
Definitely.
I've actually done this very thing about a topic that you are very well versed on. I have been learning Kubernetes. I've
Exciting.
created my first ever cluster. I have
Okay.
never been on this side. I've been on the other side testing like a full application that's already built for me. But to actually go into deploying something on a Kubernetes cluster, there's just so many things that I had to learn. Luckily, I have Simme here who talked me down a few times and explained some, I'm sure, very basic things that he already knows. It was really helpful.
I
That's
think you've been
exciting. Yeah.
doing great. It's really hard, and especially Kubernetes is, I think personally, really unapproachable still. Even if a lot of work has been done on making the journey more pleasant and more approachable to more users, it's still really opaque if you come from a developer background where you're used to doing these sort of things. It's just that big and that complex, and it really takes a change in mindset to really understand it.
Yeah, I mean, with Kubernetes, you're so many layers of abstraction away from where the code is actually running, right? Like I write my code, then I bundle it in this container, then it gets wrapped in a pod, then that pod gets scheduled onto a node, which corresponds to a VM, which then corresponds to the computer that's running underneath it, right? So the line of code that I write and execute is what, 5 or 6 layers away from the system that it's actually running on. And some of that is transparent to you as the end user, but still just wrapping your head around this fact that there's so many steps along the way to understanding what's actually going on under the hood is certainly a tough learning curve to get started with.
Yeah, looks like Daniel actually, he's one of our SRE employees, and it looks like he's agreeing with the sense that K8 Kubernetes might look like a mess for beginners from the outside. Cool to see, Daniel. Good to have you here.
Can we also start with the fact that K8S is an abbreviation that like you have to be in the know to get, because I had no idea why it was being abbreviated that way. If anyone's wondering, like I am, there are 8 characters after the K. That's why it's called that. But just like as an introduction, let me try and explain in very general terms what Kubernetes is, and you both tell me if I've got it wrong. The way that I understand it is it's kind of like a container of containers and more. So like going from like the one step back would be having containers, usually Docker containers on nodes, and the way I understand it is that Kubernetes takes that, wraps all of that into a box so that that whole thing, not just the individual containers or the nodes, but kind of it has a wider scope than containers normally do. But it makes that into like this bigger abstraction layer that is also itself a container. But I think that the idea is still the same. You're trying to make it replicable and identical so that it can be deployed elsewhere. Does that sound right?
Yeah, I think that's pretty good. The word that I hear people use most often when describing Kubernetes is that it's a container orchestrator. So if you have all of your applications wrapped in containers, which as you described are these objects which we can deploy consistently across many different places, so that we want to take those and be able to schedule them across some compute. And Kubernetes helps to abstract away what that compute actually is. So under the hood, it might be a bare metal server sitting in your server closet. It might be a virtual machine on Google. It might be a virtual machine on DigitalOcean. If you are working with Kubernetes, you don't have to care as much about what physical devices your software is running on. And Kubernetes provides this nice abstraction layer where I can say, Kubernetes, I would like 3 copies of my application. I would like them to have this many CPUs, this much memory. I would like them to be networked in this way. And you declare all that. You write out this declarative configuration, and you hand that to the Kubernetes control plane, and then it goes off and handles all the details of scheduling those workloads onto whatever compute resources are available. So that's sort of how I think about it, is like it takes what used to be a lot of manual effort to do things like no zero downtime deployments, where I have one version of my code and another version, and this one's running and this one needs to be running. How do I make that happen without having downtime? Kubernetes has a lot of that baked in, where it can spin up the new versions, load balance across the new versions partially, one at a time from one pod to the next, and allow you to move from an old version to a new version with no downtime. So there's just a lot of niceness that historically you would have had to build out tons of scripts and functionality to handle that are baked into Kubernetes from the get-go.
And that's actually why I have been making a concerted effort to learn more about it, because I think a lot of testers think, oh, that's not something I'll ever need to know. And while it's true that testers probably wouldn't be expected to do the deployment, I think that there's a lot of value that you can gain from that knowledge. I think the first thing that I can think of is that this makes test environment management way easier than it normally is, because as a tester, I'm always faced with like delays because the production like environment isn't up, or some other team wants it, so there's contention for the same resources. But something like Kubernetes distills all of that down to flat files, manifests that are then directions for how this whole application is built. So you can take that and create your own, and you don't need a full team to manage that and spin one up for you just for your particular purpose.
Yeah, I think ephemeral test environments are a really interesting use case for Kubernetes, where you can spin up your entire application stack, front end, back end, even a copy of your database, maybe with some minimal data, uh, and do so very quickly and easily. And then when you're done, it's just as easy to tear down that whole set of resources. And if you have something like auto scaling turned on for your cluster, you can not be paying for those compute resources when you're not using them. So, excuse me. So if during the day you have a big testing team that's spinning up lots of different environments to test new features as they come in, you can do so, and your cluster should just expand to satisfy that demand. And then in the evening, when the team is done and has torn down those resources, ideally, if you have it configured correctly, those additional nodes that you were paying for during the day will recognize the fact, the Kubernetes server will recognize the fact that they're no longer being used and shut those down. So I think it's a really powerful paradigm.
I used to work or consult with a company a couple of years ago, and we actually decided to do exactly that. We wanted to have, like 10 or 12 deployments a day. Basically, we wanted everything that was committed and pushed to be deployed to production. And while we didn't use Kubernetes, we opted to use serverless instead, and using AWS Lambdas for that. But the idea is kind of the same, right? So we had a pipeline running to deploy our code. And what it did was that it first did some, unit tests and integration tests and things like that directly on the runner. And then once that was done, we just spun up a test environment, deployed all the code, copied the production data, ran all the end-to-end tests automated. And then once that passed, we just tear down the whole environment and push it further into prod. And it makes such a huge difference. When I started working with code or with tech many years ago, that was completely impossible. That was before the era of even Docker. So having a test environment and setting that up and getting everything to work, that could take weeks, worst case.
Yeah.
I think it also fundamentally changes what you need to test in an application that's on Kubernetes, because I think that you still need to do all of the normal tests that you would do, but I think there's also a stronger element of static testing, because before you go to the step of going to the end-to-end testing, maybe we as testers should also just look at the actual manifest files to see whether it's been configured correctly, because there might be things that you can spot at that level before you even apply those files to your deployment, right?
Yeah.
Definitely.
So I was thinking things like actually Danielle, who's in chat, he pointed out to me that perhaps I should put resource limits, because I've been doing some chaos experiments on my cluster. And he said maybe I should also put resource limits on my pods, because I was kind of thinking, well, my pods are running, they're available, they're not terminating or anything, so it should be fine. But his point was, just because they're up doesn't mean that they're functioning correctly. And that's not really something that you would have had to consider if you weren't doing this on a cluster.
Yeah, so I think you want to have health checks to make sure that they're doing what you think they're doing. So you can configure your application with some maybe a /status route if it's an API, and you can hit that and tell Kubernetes to periodically ping that route and look at the result and decide whether or not your pod is healthy. The pod resource one, though, is a good one, because the more information that the scheduler, so behind the scenes, there's this software within Kubernetes that is deciding which nodes have availability, where can I take this resource that Nicole has told me she wants to deploy, and where can I put it? And so the more information that scheduler has about the demand of the current set of workloads, so if it knows I've scheduled pod 1, 2, and 3 on this node, and they require 2 vCPU each, and I only had 6, I know I can't put it there. Whereas if you didn't tell it that, then it might think, looks like there's some room, I'll just shove it in.
Yeah.
And so you can run into issues then if you have a bunch of workloads that are using specifically more memory than is allowed. So On the CPU side, my understanding is that Kubernetes treats CPU as a compressible resource, so you can put lots of things on, and if it's overloaded, each of those will just get sort of throttled. Like they'll have less available CPU. But on the memory side, if there's pods, if there's too many pods on a given node that are consuming more memory than exists, that is not a compressible resource. And what happens is, though some pod, and there's a sequence of rules that Kubernetes will follow, some pod will get evicted, it's called. And essentially Kubernetes just says, you're using too much memory, boom, you're done, like get out of here, and kills that pod and then has to schedule it somewhere else. And so by putting those resource requests and limits, it allows Kubernetes to understand and carve out enough resources so that doesn't happen. So that's sort of the benefit there.
Yeah, I remember a couple of years ago when I first got into Kubernetes and moved to Kubernetes from Docker, and had quite a harsh awakening when I ran a single node setup, scheduled a lot of things on it, and then the memory, just exploded and containers were killed. And that's not something you would ever have happened to you on Docker. But given how Kubernetes is built to run on multi-node environments, that's a natural response to that situation. So that was really weird. And you were like, but where are my pods? You can't just evict them if there's nowhere else.
Evicted.
Yeah.
Like what? Yeah.
But one thing that I wanted to mention, I read an article a little while ago by a fellow named Nihil Jha, who wrote a tutorial about Kubernetes, or an intro, where he did such a nice job explaining what Kubernetes is about. So what he said was that Kubernetes is a container orchestration system, but that's not the point. So just to quote him, because I think it was so profound, notice how my definition of Kubernetes doesn't include the word container. This is on purpose. The main idea behind Kubernetes is declarative infrastructure management, not running containers. So what he wanted to make a point of was that it's probably more reasonable to think of Kubernetes as an operating system, a distributed operating system, where you tell the operating system to launch certain programs and run them and schedule them in a way that's effective to both the CPU and the memory, which is more like how, for instance, Ubuntu or any Linux distribution works, more than a actual container management system. Or if you look at the previous generation of similar systems like VMware, vSphere, or what have you for virtualization, they were more of orchestration systems, whereas Kubernetes more of a operating system. Really, I really liked what he was trying to to communicate there.
Yeah, I think one of the keys for me is that it allows me to think less about the node or like the VMs that need to be provisioned, and just gives me one layer to interface with. As sort of an OS for the cloud, or my personal cloud.
I think it's funny how so many topics in tech or in software development in general go back to the principle of atomicity, which is all about simplifying everything to a very small independent module that can then be replicated or expanded or scaled up. I mean, this is the foundation of containers, but it's also the foundation of, keeping your blast radius small in chaos engineering, or system testing before you do system integration testing. Like, it all comes down to, if you find that small module and you get that part down really, really well, then there's so much more that you can do with it to build on that. I also think that to go back to what you were saying before, Sid, about the difference between the layers, like there's the container level, the pod level, and then there's also the node level. One of the gotchas that got me was that I set up a pod to have a replica. So there were two of them. And then I realized, I think Simme pointed out, those pods are on the same node. and I hadn't thought to like make sure that they were on different ones. So there's this concept called anti-affinity, where you can set the pods so that they try not to be on the same node. And that's really important, because if you have two replicas but they're on the same node, then that doesn't protect against node failure. That's a concept that I think is an interesting one when you're looking at testing an application on Kubernetes that you wouldn't have otherwise.
Definitely, yeah. I mean, I think whenever you're thinking about high availability, you need to think about all the different potential failure modes, one of which you just described, sort of the underlying compute resource might explode or catch on fire. You got to handle that. So if you can schedule them across multiple nodes, that's great. There still is some benefit to having multiple pods or replicas running on a single node, in that if one of those pods got overloaded and became unhealthy in a way that was independent from the underlying hardware or virtual machine, you would still be able to load balance to the other one. So there is some benefit, but you're right that you wouldn't get the full benefit of completely scheduling them separately.
And in your particular case, Nicole, because I know your environment, I've seen your two nodes
very well, unfortunately.
There you have another issue that we didn't really address, but which is interesting as well, where if the first node dies, the one node that contains your ingress and your service, then you're out of luck anyway, even if you have a pod on the other node, unfortunately. So there are a lot of gotchas that might be hard to, that requires you just experience and stepping on landmines to learn.
Yeah,
it's a little overwhelming, honestly.
For sure. Even just like knowing the various command line incantations of kubectl to get the information you want out is a big bar. There's this tool called Lens. I don't know if you've looked at it at all. Their branding is like an IDE for Kubernetes. I don't really like that branding because you shouldn't be modifying those resources directly through this software, but it gives you a really nice visual interface for exploring your cluster and the workloads within it and all the configurations. And so I use it just as sort of a tool to look in, to provide a lens into my cluster, but I never change any resources within it. And I would suggest that others avoid changing resources within it. But as a tool to help speed up your debugging process of, I need to find the logs of this unhealthy pod, or why this deployment is unhealthy, etc. It's a pretty powerful tool.
K9s? K9s is also a UI, I think.
I don't know K9s.
To me, I have only looked at it briefly, but it's a lot like, maybe you've heard of Portainer that people use on Docker. It's kind of along those lines, but for Kubernetes. I think you might even have Portainer, Nicole, on your NAS.
I do.
I think so.
Maybe.
Synology
Simme knows more about my stuff than I do.
Synology NASs usually come with an installation of Docker as well as a Portainer installation, and I only know that because I maintain Watchtower. So it's not that I actually used it myself.
So a really cool thing that I liked as a tester is that I didn't. I mean, okay, granted, I did have to bug, my tech support, Simme, to help me set it up. That was mainly to set up the application, though. But once we had those manifest files right, I felt like I could do anything, and if I destroyed the application, well, it's not difficult to just do it again, to just spin it back up again, because once you have those files, that's all you need. They are the environment. They're the instructions for the environment. And it just made me think about like disaster recovery type or failover scenarios that I've done previously, where I had to run a load test, and then I had to talk to like the ops team and say, hey, okay, now can you turn this one off? All right, can you look at the logs? And it was just, there's just so much around it. There were resources, people that were tied up in this one exercise that I can now just do on my own single-handedly. That's awesome. It's like a superpower for a tester to have this capability, this knowledge. I don't need anyone. I don't need an ops team yet.
But I think that kind of goes back to what you were saying previously about being curious and not, having the right mindset. Because, I mean, basically what you're saying is, or at least how I interpret it, is that, which I also agree with, is that you shouldn't really be satisfied with black boxes, right? So if you stumble upon a black box and you feel like, okay, this is way out of my comfort zone, just tackle that. Take a first step and see where it goes. I mean, sometimes it could be beneficial to just, come to the conclusion that someone else will handle that for you. But usually it's really helpful to have an understanding of it, no matter what role you're in.
Yeah,
I totally agree.
Yeah, I think the more you can help yourself get unstuck out of challenging situations by understanding what's going on inside that black box, the more productive you'll be, regardless of the role. Anywhere across the entire software lifecycle, I think it's useful to be able to peer under the hood and see what's actually going on.
And what about like defect replication? Now, instead of it's not working on my environment, I can't reproduce it, kind of back and forth between a tester and a developer, I can just be like, well, here are the files that I'm using, see if you can reproduce it here. And it's just so much easier.
Yeah, I think declarative configurations like in Kubernetes, and then infrastructure as code is another topic I know we want to touch on. But those two things paired together mean that you have an environment that not only is the software environment reproducible as this container, but also the hardware and the infrastructure that it's deployed onto is also reproducible. So I think, yeah, it's a powerful combo.
Okay, so tell us about infrastructure as code.
Sure, be happy to. So infrastructure as code is this concept of trying to move away from doing anything manually. So maybe historically, or if you're just getting started out, you would go into the cloud, whatever cloud of your choosing. So maybe GCP, maybe AWS, maybe DigitalOcean, who knows? And you might go into their console and click the button and say, give me a virtual machine. And then you might go into the networking tab and say, configure the firewall for this machine to allow HTTP traffic. And then you might go and take all these manual steps, right? And that's great. And it's easy. It's an easy starting process and you can get up and running. But now what happens down the road if you have some issue and you need to go redo all that? One, it's a lot of work to go redo it. And two, every step where there's a human in the process, making a decision or clicking a button or typing a command is another potential place where you could introduce a bug. So you might click the wrong button on the network config and now you have a hole in your firewall. And so infrastructure as code is thinking about how you can move away from those manual processes and turn them into configurations that you can check into your code base, that can be automated, that you can audit for changes and see within Git, okay, what changed about my infrastructure from this commit to the next. And so there's lots of tools for doing that. I think even just moving from clicking in the UI to having a one-off bash script that spins up your infrastructure is a positive step. But really, the end goal should be to get your infrastructure also defined declaratively, like we were talking about with Kubernetes. And there's tools like Terraform, CloudFormation. Google has their own deployment manager tool, or the CDK now I think is the new hotness, where you're defining everything as Kubernetes resources. Haven't really looked into it too much. But yeah, you can define your entire infrastructure, including the virtual machines, the networking, everything, as a configuration, and then automate the deployment of those configurations onto the cloud of your choosing. So Terraform's the tool that I have the most experience with within that space, but I think there's lots of options, and moving towards any of them is better than manual provisioning.
Yeah, I used to work with Azari. Oh, sorry. Go ahead, Nicole.
Sorry. I was just going to ask if, was it Argo? Is that also in this list of tools, and Ansible?
Ansible is a configuration management tool. It is generally imperative in nature, so you're defining these playbooks where you say provision 5 VMs for me, do X, do Y. It's still a powerful tool it has a place, and I think pairs nicely with Terraform. Whereas Terraform, you say, I want my end state to be 5 virtual machines with this configuration. And then there's what is known as a provider. So there's the Terraform core software, and then each cloud provider has, or each cloud, I don't want to use the word provider to define it. Each cloud service has a provider, which is a piece of software that interfaces between the Terraform core software and the API of that cloud. And so when you tell Terraform, give me 5 virtual machines, it then queries the cloud API to get the current state of the world. It says, how many VMs do you currently have? Is it 0? Is it 10? It then compares that state against your desired configuration state, and it calculates the delta between those. So it says, you have 7 VMs. You told me you want 5. I need to take off 2. And what are the API calls to do that? And all of that is kind of transparent to the user. And then you say, yes, take away those 2 VMs. It will then make those necessary API calls on your behalf to get it into the right state. Whereas Ansible, you say, give me 5 machines. And then if you run that same playbook again, it gives you 5 more machines.
Right,
so that's sort of the difference between the imperative approach and the declarative approach.
That's so good. Thank you for explaining that to me. I've heard the terms thrown around, but now I understand that it's not really, it's kind of a misnomer to call those, to call them instructions. They're not really instructions, they're more descriptions of the end result rather than do this in this order.
Yeah, so imperative is the instruction, the recipe, do X, Y, Z. Declarative is the end state. Here is what I want to end at.
Get me there.
Yeah, and then the tools abstract a lot of that away. So Kubernetes says, give me a declared end state of how you want your application configured. I'm going to go figure out how to do that. Terraform, same thing, but on the infrastructure side. Tell me how you want your infrastructure to be, and I will try to figure out how to do that.
So I'm sorry I interrupted you, Simme. What were you saying earlier?
No, I was just going to say that one of the things I really like about infrastructure as code is the notion of, or I don't know if this is really part of it or if it's just something that we've been practicing where I've been, where you say that, for instance, the moment someone logs into a server using SSH, for instance, that moment that server is compromised and you should probably replace that. And that kind of plays nicely with the whole idea of infrastructure as code, that no one should need to be on the servers. No one should really even have access to the servers because you don't need to. You can just use your, for instance, Terraform definitions or what have you instead and have that do the change. So it's really, really traceable and it's predictable in a way that it will never be when you do things manually.
Yeah, I think it's a major mindset shift from thinking about your servers as these physical devices that took me weeks or months to provision and set up in my data center on-prem. And that situation, you probably are thinking it's going to take me on the order of weeks or months to get anything new or changed. And so you start to think about it as this long living, mutable resource that you can go in, you can log into, you can install things, you can change things. It's kind of the cattle versus pets mentality, if you're familiar with that. This idea that you should treat your server as cattle. You don't name your cows. You shouldn't treat it as a pet where you love it and you care for it and you think about how you should craft its updates, etc. And so, yeah, the mindset shift with infrastructure as code is moving from this world where I have this long-lived resource that I need to take care of and install updates on. Whereas with infrastructure as code, you think of your infrastructure as short-lived, immutable objects, which if you need to make a change, you just take down the old one and bring up a new one. And so it's really a big change in how you think about things. The other point that I'll bring up is that if you want to go the infrastructure as code route, you need to do so and not fall back to SSHing into that machine and making a modification. Yeah. So if you define everything as code, you deploy it with Terraform or whatever, and then something's broken, you need to be committed to update the code and fix it and have Terraform apply that change versus going in, hot fixing something, then the next time you apply your Terraform config, it's actually going to break it again, right? You're going to revert to the old version. And so you need to make sure to be diligent about rolling any changes that you make need to be pulled back into that configuration, or you end up in a state where your configurations are no longer trustworthy and in fact are dangerous and you can't run them safely. So I think making sure that you understand that and are making a conscious decision to do that is important when thinking about infrastructure as code.
I think most of us have probably been there, right? Where you had a critical, situation where you logged in and done some kind of command, and then the next time you deploy, you're like, okay, but now we're having this issue again. Yeah, it's because whoever SSH'd in and fixed it last time, so we haven't updated the definitions yet.
Right, but he or she is on vacation right now. So what did we do? I don't know. Can we get there? Can we call them from the beach?
Yeah, they'll be happy about that.
Let's try to read through the SSH command history of whatever
no.
to see if we can find it.
No, but you already did your Terraform apply, so it tore that one down, so it doesn't exist anymore.
So this is kind of like a way to enforce best practices too, making sure that people aren't just making like hot fixes to one server or whatever instead of changing the definitions. And it's also kind of like enforcing documentation.
Yeah,
because you're kind of documenting as you go.
That's one of the biggest benefits I see of infrastructure as code is it gives you a place within your version control system that should contain exactly the configuration that is running in all of your environments. And so if you and I need to go in and think about what changes need to be made or the next iteration of our infrastructure, we can sit down and pull this code up and reason amongst the shared understanding of here is what it is. We have high confidence that is what is actually deployed in staging, that is actually what is deployed in production. And where do we go from here? Versus historically, if you had deployed it through the GUI or command line one-off commands, now each of us in this room have a slightly different understanding of what is actually deployed. And all three of those understandings are likely different than what is actually deployed.
Yeah. Do you remember back in the day when you usually had to do a change request to get a change into a server in production?
Yeah.
And probably there were a change advisory board that would consist of different managers that would decide whether the change was safe to perform or not. I'm so happy that I've moved into, the regular code workflow where you do pull requests and your peers will, scrutinize that request and see whether something will break when you apply it, instead of having to, defend your changes against a board of managers that probably have no idea what you're going to do anyway. It's such a nice change.
Yeah, that sort of sparks a thought around deployment frequency. And there's been so many studies that come out that sort of tell the story that the more frequently you are deploying, the less downtime you actually end up having and the better quality your software has. And so I think there's situations where a team is having issues, they're struggling, and the instinct is to like do a code freeze, right? Like we got to cut down on these bugs, we're going to freeze it and like test everything so thoroughly. But what happens is you end up with so many changes in each deployment. If you've waited a week or you wait 2 weeks and now you've got a full team of developers building and adding features and modifying things, that it just becomes so much harder to catch all the potential edge cases and corner cases versus being able to just deploy rapidly across software or infrastructure things is just such a better paradigm where each change is so much smaller that you're able to actually understand how those changes will manifest. And if there is anything wrong, it's so much easier to target. It was this commit or it was this release that introduced those issues.
And that really isn't as hard anymore either. I mean, with concepts like feature flags being available as cloud services or whatever, it's really quite nice to be able to do that, because you can actually decouple the actual delivery or the deployment of the code to actually releasing it or giving it to users. So you'd be able to, each commit you actually push to production immediately, and you have it there. But then you don't turn it on for users until you tested it thoroughly, or you know that it works, or you're ready to do your release campaign or what have you. I think that really adding that layer with feature flags, that really enables teams to do what you're talking about and do it in a successful way.
I think that one of the benefits too that distilling an environment down to these definitions is that those definitions can then be versioned. So now we have versioned environments. You're not relying on specific people to build an environment for you. You can look at the code yourself and see what changed from one to the other. And there's no ambiguity, because I think when a testing team moves to another testing environment, like from system integration to pre-prod or something, the first thing you do is verify that the code base actually is correct, because a lot of times there's a lot of ambiguity on that, because there's not just one version for everything. There are many different components that can be changed. And I think having that in a definition is like, there's no vagueness to it. It is what it is. You can see exactly what was included in that build.
Yeah,
So
I think.
I have a question though. Would you say that would Kubernetes be part of infrastructure as code, or is infrastructure as code only the underlying hardware?
Yeah, that's a good question. I normally don't think of the workloads deployed into Kubernetes as being part of infrastructure as code. I think of that more bundled with the software itself. I think some people would include it. I think the definition of your cluster and the deployment of your cluster certainly should be included in that infrastructure as code. But whether or not the YAML files that make up your deployments, I think, yeah, it could go. I could see it falling in either camp. What do you think, Simme?
I'm definitely in favor of treating it as infrastructure as code as well. And I think that's where software like Argo CD that you were mentioning, Nicole, that's where that comes in. You'll be able to apply GitOps principles on top of your YAML files or your Kubernetes workloads, because it's the same with them, right? If someone goes in and does a kubectl edit of a pod and just changes the replicas or whatever, then all bets are off in that case as well. You don't know what will happen anymore. Whereas if you treat it as infrastructure as code, then you have that repeatability, you have that history or tracking of it. So I definitely think it's good to consider that part as well, even if it might complicate things a bit.
So it sounds like Terraform or a similar tool is kind of like Kubernetes, but at the node level, at the server level. Is that a good way of thinking of it, or is it something else?
I think they're analogous in that they're both they're both enabling you to define resources declaratively as like the key core tenant that they share. So something like a Terraform is providing that layer for cloud resources. So that could be network, that could be compute, that could be storage, whereas Kubernetes is providing that for your application itself. So slightly different, but I think they do share that core tenant that they are allowing you to define things declaratively, and they take care of the details once you have done so.
One thing that I'm really curious about is Have you been in any do you have any experience with teams that are currently not using infrastructure as code principles, but would like to move in that direction? Maybe they want to start a new project or whatever, where they want to where they want to apply these principles. Have you done that? Do you have any advice for such organizations?
Yeah, I think I have worked with some companies who are in that situation and have gone from no infrastructure as code to some portion approaching 100%, not at 100%. You'll probably never get to 100%, but I think the key is that while you do need to treat any given resource that is managed by Terraform and only modify that resource through infrastructure as code, it doesn't need to be all of your resources in that config. So for example, if you are running on Kubernetes and your initial deployment, you provision through the Google console, just click the create me a GKE cluster, and you've been working with that and it's fine. You can create a new cluster and define the configuration for that in Terraform and start to migrate your workloads onto that once you have it established. So that's one approach where you can sort of bring up a parallel resource that is similar and then move it over. You can import existing resources into a tool like Terraform. The workflow there is a little clunky. I was actually just making some content around this, but like let's say you provisioned a server through the GUI. You can then go into Terraform, find the resource ID from the cloud provider. So let's say you go onto Linode and you find this VM is ID and then some 8-10 character number. You can then define an empty Terraform configuration corresponding to that VM. So say I've got my Linode virtual machine, and then you can run the Terraform import command, and that import command will go off and find all the information from the API of the cloud provider and pull it into your Terraform state. And then there's one more step. It doesn't actually generate the resource configuration. So then you have to type out or copy in the necessary configurations into that resource block. And so it's a pretty manual process. Once you do that, now that resource is within your Terraform configuration and you can manage it using your infrastructure as code. So it's a little bit painful up front, but it is possible to bring in existing resources. So I've seen both of those approaches used, sort of basically creating a parallel resource and shifting the workloads over and then tearing down the manual one, or taking the existing one and importing that in and using that. So either one can work. It is a large effort to do it, but I think it's worth it in the end.
Yeah, and the same could be said for Kubernetes as well. I mean, maybe you've deployed a Helm chart or you just used kubectl to create what resources you want, but then you can actually get them with kubectl and output it as a YAML and save it as your manifest files afterwards, which is really, really nice. It kind of allows you to experiment a bit, and then once you've got what you're going for, then you can just export it and have that be your configured state or your infrastructure as code definitions.
Yeah, there's also some really nice tools that will lint your Kubernetes resource definitions, both for correctness, but also for best practices. So you can run it against your deployment, and it will spit back out, hey, Nicole, you forgot to give me CPU and memory resource requests. Would you like to do that? And so it can tell you, it can tell you sort of where you are not following best practices, such that you can go in and start to add those. I only called you out because you said that before.
No, that's totally true. So what would it be called?
I'm forgetting off the top of my head what it was called specifically.
Because it sounds like something I need.
Meanwhile, Daniel is suggesting Terraformer for inverse Terraform operations. I haven't used it myself, but
I've used it once. I've used it once, and it was helpful. There was one thing in particular. I was trying to set up like a monitoring alert on GCP, and it was unclear from the documentation exactly how to do something. And we had already set one up manually, and so I think it was Terraformer to grab the existing resource and convert that into a configuration file, and then we were able to take that and with a few tweaks get it up and running.
I just love the name Terraform. It is so descriptive of what it actually does. It's like going to a barren world and then creating something new out of it based on instructions. I love that name. It's so appropriate.
Yeah, the tool that I was thinking of before was, I think it's called Cube-Score. I just linked in the private chat. I don't think I can send a link to the K6 chat because YouTube doesn't like when non mods try to link things in the chat. I think it hides
and there's
them.
also a kubectl doctor, which I think does something similar as well.
All right, that's cool. I'll check it out. And so, are there situations where you think that Terraform would not be a good fit?
Yeah, I mean, I think the Terraform works best where you have someone else who is managing these resources and you can provision as many as you want and tear them down whenever you want. So that's most modern cloud providers. They need to have an API from which you can do that, and ideally a Terraform provider that interfaces with that API. You can write your own provider. I have not done that yet, but I hope to do so soon. I'll probably play around with that in the future. But yeah, if they have an API and you can bring up and tear down resources using it, then it seems like a good fit for Terraform. If you are managing your own hardware, there's less benefit because you still own that hardware, and it is a capital expense that you can't really take off your books. And so there's less use in sort of being able to scale up and scale down and provision new things and tear them down. In that case, you still want infrastructure as code to provision those servers and get them configured with all the necessary dependencies, but that may or may not be Terraform as the best tool there. You would probably want something more focused on configuration management, maybe an Ansible or some other tool in that class.
I think there is a provider, for instance, for OpenShift, but I haven't tried it myself, so I don't know how well it plays. And the same, I guess, it goes for DigitalOcean as well. I think there is a provider there as well, but I think it might be of limited use as compared to on GCP or AWS or Azure.
Yeah, I've used GCP, AWS, Linode, DigitalOcean. I know Vultr has a provider. I think most cloud providers these days have a provider. The coverage across the resources probably varies a bit, but I think most of them have a reasonable coverage where you can get what you need to done.
So infrastructure as code is not really for on-prem solutions, is it?
No, I think it still is. It's just a different style of infrastructure as code. Rather than bringing up a new server from nothing, you have a set of servers that you own, and you need to configure them in some way with some set of dependencies and networking and how you want them to communicate with each other. So yeah, I think it's still very valuable for on-prem. It's just a different style.
And it wouldn't be 100%.
Probably not. I mean, unless you have a robot that is going in and doing the network plugging and.
But that's interesting that you say, Nicole, because I actually have a Kubernetes cluster in my wardrobe. So
is it Raspberry Pis or what is it based on?
No, it's actually based on my old gaming computer, so it's actually quite capable. It runs a couple of heavy workloads. But what I've done there is that
it's running K6 Cloud, the whole thing.
Actually not, but I should probably try that. But in any case, in that case, when I do a change to my infrastructure on GitHub and push that to the repo, then that will actually be applied to my cluster as well. So you can still do it, but as Sid says, given that you actually have hardware, it's hard to have that hardware change, right? But in my case, I only have a single machine and everything on it is virtual. So in that case, it works really well.
I just pay for DigitalOcean. That's where my cluster is. It's just so much easier.
All right. It looks like we're actually running out of time. Time really flies by. I have a lot of more questions that I'd like to ask you, sir. But I guess we'll have to schedule another session at some point because this was a blast.
Yeah, this was super fun.
Do you have anything that you would like to do a plug for or anything before we end?
No, I think just if people are looking to level up their DevOps and cloud infrastructure skills, come check out. I have a YouTube channel that goes by the name DevOps Directive, DevOpsDirective.com, and then on Twitter, my handle is @Sid Palas, and I try to release one video a week, but trying to ramp that up, and then try to put out one useful tweet a day.
And you can also find Sid's blog over there.
Perfect.
You can also look at the description of this video. I put your Twitter, your YouTube, and your site.
Awesome. Thank you.
Thank you so much for coming on the show.
Yeah, it was a blast. Thanks for having me.
All right.
All right. Thanks, everybody, for listening. See you next week.
Bye.